Last week, we have learned how to generate hypothesis testing, how to compare the means of the population and its samples. We also learned how to calculate the interval that contains the population means with a specified amount of the confidence. We also learned how to compare two sample means when those two samples are independent or dependent. I also show how to calculate the mean, median, confidence interval in the R statistics software. I also show how to calculate the t-test in the R statistics software. This week, we will learn the simple linear regression. Simple linear regression is a basic statistical model. It has been used into many areas. It also has been used to the auditing. Before we introduce the simple linear regression, let us first take a look at the Pearson Datasets. Carol Pearson, he collected the heights of the fathers and their sons. In order to use this dataset to study the relationship between the father's height and their son's height. He collected total 1,078 measurements of the father's height and his son's height. You can see this dataset in the scatter plot. In the scatter plot, the x-axis is the father's height in inches. Y-axis is the son's height in inches. This dataset has been used by Pearson to investigate the regression. When you see these data points, it seems they are randomly located in this graph. If you carefully see this dataset, you may notice those datasets that are located with a certain direction. It seems they go to this direction. I would like to ask, how would you describe the relationship between the heights of the fathers and the heights of their sons? If I give you a father's height, what height would you predict for his son? In order to solve those two questions, we can use this method. First, let's take a look at. So we choose a portion of the fathers with a height from the 62 to 64, and we choose another portion. The father's height is from the 17 to 72 to 74. We choose those two portions. Those two portions, and you may notice those father's height ranging from the 62 to 64. Their son's height ranging around from the 63 to 74, and the father's height ranging from the 17 to 72. Their son's height ranging from 62 to 75. So we can calculate the average height of those sons when their father's height ranging from 62 to 64. We use the red cross mark to show the average height of the son when their father's height in the certain range. And the same thing for another portion. We calculate the average height of those sons. We use the red cross marks. And you can say based on the average information, though the father's height is ranging from the 62 to 64, their son's height is actually 66. And the father's height ranging from 17 to 72, their son's height average 71. When the father's height is higher, the son's height is higher as well. But this just happens on average. Let's take a look at these data points. So this beta point, even though the father's height is located in this portion, but the son's height is around 74, it's higher than the average height of those sons as when their father located in this portion. And for this portion, let's take a look at this observation. This observation, even though the father's height is high, but their sons, the height is shorter. It's lower than the average height of those sons that's when the fathers in this portion. So we can treat those data points as an outlier. So in order to take a look at the relationship, we can calculate the average height of those sons based on the father's height. So we can first calculate the father's height is 61, get the average height of the son, so it's around 65.5. For the father's height is 62, their son's height average is 66. And for the father's height is 64 and the son's height is around 67. We keep doing this and to calculate the average height of the son based on the father's height. We use the red max to show the average. So you may notice the relationship between the father's height and the son's height is nearly linear. The simplest way to describe the father's height and the son's height is use the regression line. So is the son's height on the father's height. We use the dark line to show the regression line for the data point. So for example, right now we have those regression line. It tries to fit all those data points. If we have the father's height 17, and based on the regression, we can guess their son's height is around 71. If we have the father's height 72, based on the regression line, so we can guess that the son's height is around 73. Right now, let's take a look at another example. Suppose right now we have the company A. It's an e-commerce company, and you have the information. It's a monthly sales and the marketing expenditure for the last 12 months for this company. We try to identify the relation between the sales and the marketing expense. For the marketing expense here, the most part will be the advertising, suppose here. And we have the first month, we have the January the sales is $90 million and the expense is $10 million. In order to identify their relationships, and we can use linear regression. We use a linear regression. The first step to do the linear regression is to plot the data sets in the scatter plots. So you can see those 12 months their expense and the sales. Based on this information, you can easy to identify the relationship between those variables. That's why we use the scatter plots, because scatter plots is a very efficient tool to identify the relationship between the variables. After we see those scatter plots, we try to get the regression line. Suppose here the regression line for those data points is the dark line. So use the dark line to represent the regression line. This line will try to fit to the historical data sets. So how we determine which one will be the better line to fit all those data sets? So we will use we call the least square method. The idea based on this method is try to minimize the errors. Let's take a look at. Based on the dark line we have, we try to calculate the errors we make here. We try to calculate, for example, based on this data points. This is actual value. We spent the 20 million marketing expense, and we have the 113 sales. The estimation value is $110 million. So the $20 million will be the error for the estimation for this data point. For another data point, for example, right now we have the marketing expense is around 32, and the actual sales is around $114, and the estimation value is 113. So the errors here will be the $10 million. So we keep calculate the errors, try to calculate the difference between the estimation value and the actual value. We keep doing this and add the sum to get the sum of all the errors. We compare the sum of errors for this regression line to another regression line. So we also calculate the errors for this line. We keep doing this, get the sum of those errors, and to compare those two errors, the sum of errors, to choose the line with the lower sum of error. Suppose here for the dark line, it has a lower error, so we use this dark line as a regression line. After we get the regression, we can use this information to make a prediction. Based on this information, you want to know the possible sales for the next month. Suppose right now you have the estimation information for the next month marketing expense. You know it is $14.7 million. Based on those information, we want to know the possible sales for this company. You can use this regression to predict the sales. We can extend this line to make a prediction. So this will be the estimation for the sales in the next month based on the marketing expense, $47 million. The sales around $160 million. So let's try to recall here. When we do this simple linear regression, we can first plot the data sets in the scatter plots, then find the regression line based on the errors. After we got the regression line, we can use the regression line to make a prediction.